Hello, and welcome to another episode of Data Lounge, where we try to take a look at a little bit more at the funnier side of data. I'm your host, Alejandro Leguizamo, and today we have someone really, really special for us, someone that we had the pleasure to work with and has a lot of patience with us, definitely. His name is Matt Usher from the Azure Synapse team. So Matt, thank you for joining us. Welcome.
Thanks for having me.
So we're very excited. Obviously, we've been following up all the very interesting pieces of announcements that we saw in Ignite, even with Rohan Kumar doing the fantastic demo about Azure Synapse. But we know also that probably we get a lot of attention to top 2-3 things, but there is a lot more that is going on with the product, right?
Yeah, absolutely. There were a lot of big announcements at Ignite around Synapse. And so, like you said, it's really easy to only show 2 or 3 things on stage as a big part of the demos, but there's really a lot of power and enhancements that were added to the product at Ignite.
Okay, what are some of those that you would say, listen, let's get the audience talking about these other things as well? Or I understand you have a lot of things prepared today. For those of you watching this, it's very early where Matt is right now. It's 7 a.m. where he is. So we really appreciate he working in these ungodly hours for all of us. So what do you have?
Yeah, so I think there's a couple of things to start with to kind of frame the conversation that we're going to have. I think the biggest one is to talk about the different engines that are inside of the SQL component of Synapse, for example, and so that way we can make sure that we're all talking the same language. So within Synapse, there's essentially 2 components from the SQL perspective. There is a serverless model, and then there's a dedicated model. So really, the ability for you to run SQL queries in either one of those approaches. Obviously, the dedicated pool is around having a system that's up and running and provisioned all the time, and an on-demand is essentially a service, or the serverless model is truly a serverless where you're just giving it a query, it'll go pull or spin up a pool of query or of compute to go execute a query, and then execute the query and then tear itself down. So we added capabilities to both in Ignite. Some of them apply to both, and some of them are just specifically to each one of those. So I'll walk through a couple of the big highlights. Obviously not all comprehensively of the things that we announced at Ignite. Probably the biggest one that will enhance most organizations is the integration that we added with Power BI. This is something we've been working on for a while. But really what this does is it's an accelerator for Synapse Analytics. And the idea is that organizations often have key dashboards, key reports that they run all of the time. And if you're doing that on top of something like Synapse Analytics, the system itself is intended now to grow and learn as you start to build your organization footprint on top of Power BI. We're really trying to enable the scenario of making the most optimal performance of those scenarios for you. So if we think about a dashboard on a Monday morning where it's a sales report and all of the sales folks are coming in on a Monday morning, everybody's going to hit the same dashboard. Well, maybe you have a developer who's sitting behind the scenes tuning that dashboard and trying to get the most out of it. But over time, the number of reports and things will outpace the number of developers that you have looking at this. And you don't really want to spend all of your time from a developer's perspective just tuning. So what this does is it allows some machine learning behind the scenes to actually look at what's going on in your organization and to build some optimistic caching models behind the scenes, whether those are applied down into Synapse or whether those are done at the Power BI level. It really allows that caching experience to be able to expose your most common reports, really speeding up the performance that the end user has. And it's really based on the usage of those reports over time. So Power BI and Synapse together are learning what customers are doing and being able to tune the system based on actual workload instead of just a theoretical, well, maybe this or maybe that, or having a developer going in and looking at every report. So this is one of the big components that we introduced. That's currently in private preview, but we'll get out to public preview fairly soon. Another big one that we've shown off in the past was, and I'm showing them here on the screen, is the Synapse link for Azure Cosmos DB. This is now publicly available to all users, and what this does is it allows a user to run a query from Synapse SQL and reach out to a Cosmos DB operational store and be able to run this in near real time. I'll have a demo of this in just a little bit, but really it gives you that whole kind of data experience and data exploration as well as data insight without having to go do complicated ETL or ELT. Not only does this reduce the complexity of your system of being able to access that data, but it also reduces the latency of that data. So if you imagine having to take data out of Cosmos DB, run it through some transformation process, whether that was an ADF copy job or something like that, and then land it in your real-time analytics store, it takes time for that to happen, whether that could be 10 seconds, 15 seconds, a minute, 5 minutes, 10 minutes, whatever it is, there's some latency in that data. And now with business moving at kind of the turn of the clock, right, being able to make data insight decisions at real time against real operational data that you're collecting from all kinds of sources into Cosmos DB is a critical feature. And so this is something that's now publicly available in Synapse.
Okay, so this is actually ready now for any client that wants to try these actually working. It's available now, correct?
It is available now, yes. So you're able to go through, and I'll show a demo of this in just a little bit so you can actually see how it works. But yes, this is something that anybody can go use today with Synapse.
Excellent, thank you.
Yeah, one of the other big things that we see is that when we think about modern analytics, you have data coming from all kinds of different sources. Some of these are operational sources like Cosmos DB. Some of these are historical kind of relational assets that you may have on premise, something like a large ERP system that you're pulling data out of, or an ordering system or manufacturing system, whatever that is. But also we're starting to see this massive trend around just having kind of common data formats. So you'll see a lot of Parquet and org files and Avro files and things like that. But you also still see in most organizations things like just simple common separated value files, CSV files. One of the big enhancements that we announced at Ignite and we have a public preview for is what we call our CSV version 2 parser. Essentially, this is a performance improvement capability around the parsing of CSV files. And if you think of that modern architecture, oftentimes what happens is that data lands in a data lake in a CSV format, and then you want to be able to either extract or read that data as quickly as possible, either ingesting that permanently into something like your Azure Synapse SQL system, or just being able to read it and being able to do data exploration. So really this is allowing you to go do that data exploration with high performance, really improving the capabilities, allowing a developer to sit there and not have to wait 10, 15, 20 seconds, 30 seconds for every time they have to read a CSV. And with capabilities like directory transversal, the ability to walk a directory of CSV files, if you're doing something like data loading from a root directory, you can really improve the performance and the capabilities of the system. Again, the goal is always back to driving the time to insight that you can get from your data. The longer that takes, the longer that it takes for your organization to be able to make a decision. And sometimes there's a massive opportunity cost in that delay. So really focused on the performance of the system.
Okay, but and that CSV, all of these elements that we're talking about here, this one is also in public preview, right? Because yes, you're absolutely right. In many cases, one of the most common formats, definitely, probably for organizations that not necessarily are working with Avro or with Parquet, is naturally CSV, right? It's probably the most natural thing that people say, hey, I need to export the data. It's going to be a CSV. So this is also available now, correct?
Yes, this is available now. And this is one of those features where if you think about organizations, we always think about from the developer's perspective, like, oh, okay, well, I'll just crack open C# and I'll get the NuGet for, Avro or Parquet formats, and I'll just go generate the stuff. But if you think about your organization, most of your developers and your data analysts don't understand that concept, right? Cracking open an Avro file, for a developer is fairly easy to do. An analyst who's just looking for patterns and trends isn't going to do this. Maybe they're getting data from an external source. All they have it is in Excel. So saving it out as CSV and be able to ingest that into the rest of the system is really a common way that people are interacting with this data. I know it seems trivial that we're still talking about CSV files as a data format, but it truly is one of those things that you see very commonly within organizations. It's really a simple exchange format that humans can understand. And so exposing that to the data analyst and making sure that they can ingest that data with the rest of the structured data or unstructured data that they have really is a capability that most organizations are now really trying to take advantage of.
Yes, absolutely. And we've seen it in scenarios where, for whatever part of that reason of data processing within the data lake, you need the input from a user, right? That the user needs to open the file and just check the contents of the file to see whether it's right or not, or it has a certain shape or not. And definitely when you give them something like Avro or Parquet, it's not straightforward. While when you have a CSV or even a JSON, it's much more direct, the interaction with the data.
And you think about, most organizations have a variety of data sources. So many of those data sources are, not modern in many regards. And so the ability to emit something like a Parquet file or an Avro file means that you're going to have to go do development work to pull the data out into some intermediate system or intermediate application, and then generate the Avro file, Parquet file. Again, this all takes time. Whereas almost every tool on the planet can generate a CSV. You can dump it from a database, you can dump it from some other system. So being able to interact with that kind of lowest common denominator kind of format really improves the performance of your data insight.
Good.
Yep. So a couple of the other big things around data loading. So we think about how do we get data into the system so that we can process it quicker. I mean, you can hear this as a common theme. We've now have at general availability what we call the copy command, and this is really automates the way that you want to load data from external sources into something like Azure Synapse SQL. This is really two components. The copy command itself is just a simplified way of being able to say, here's some data sitting in blob storage, for example, or data lake, and I want to be able to ingest it and land it in this table. There's a couple of components around that really make this a much simpler model. If you think of what that data source is and having to generate the column and data structures for that into a table, it really makes it a little difficult if you have very large tables or very large data sets that you're pulling data from. So if you imagine you have a Parquet file that's got 100 columns in it, not a lot of developers want to sit down and write, okay, column 1 data type, column 2 data type. That just takes time. So not only with the ability to just ingest that data high performance, we also have what we call automatic schema discovery, where we can investigate the Parquet file and generate the schema for you, especially in these large table scenarios. Being able to go, auto discover and auto table create that structure into something that lands in, say, Synapse SQL. Really saves times for developers really getting started of, okay, here's the data I'm getting from a partner, from another system, and how do I generate that into something that's useful? Also, too, things like complex data support. So you can imagine, all of these different systems that are either generating, Parquet or Avro file, for example, or that are consuming those all have different structures, data structures. Some have an array data type or a period data type, and how do we generate those into something that Azure Synapse SQL can understand, so that we do all this kind of disparate data type matching. So this is also something that's handled in the copy command. So we can do these kind of complex data type support to be able to map all the data types back and forth, so that we can make sure that you can take the data from any one of the source systems that you can generate and land that into Azure Synapse SQL for further processing. It really makes it a lot simpler for you to manage this whole process. Again, the goal is that you can write this in a T-SQL statement. You don't have to go through a long kind of complicated ETL or ELT operation to go build a whole model of importing this. You can simply just write some T-SQL code and pull that data in as quickly as possible. So this is another one of those capabilities that's now generally available. So it's available to all users at what we call the GA quality bar.
Perfect.
Yeah, and another one that we GA'd here, and again, I'm showing these on screen here as kind of we go, and obviously you can see the URL, so folks can go read a little more about each one of these. But is if we think about what kind of modern architectures are doing, I mean, in the past when we talked about a data warehouse, you really talked about that kind of the warm and cold path of a Lambda architecture, where you have very hot streaming scenario, and then you have kind of warm and cold data. So if you think of something like, I use web servers as a common scenario. You have reporting and analytics around web servers where you say, what's the number of users in the last 5 minutes on our site? And then you also want to merge that with data like, well, is this comment on this time of day on a Tuesday morning? Well, maybe not. So that really is that insight that you're looking for. Are we having a traffic spike as compared to our normal average, or is this just a normal Tuesday morning? And so you want to be able to merge those two data sets. Historically, other systems, including Synapse, have forced you to build that at essentially the BI level. So you have a hot path that's pulling data through something like Stream Analytics. You can show that data in a view, and then you potentially have another view that shows, here's my historical data of a Tuesday morning. What's traffic over, the early morning hours, and then maybe able to map those two. So you can visually look at it and go, oh, okay, this seems about right. This fast streaming ingestion allows you to push that IoT data directly into the SQL engine from Stream Analytics and be able to run join queries. So you can imagine a query that says, show me all of the users that are on our site right now, and historically, what's the pattern that they've had, or what's the engagement that those users have had. So you can merge both of those streams of data into a single query, giving you that real-time insight as well as the historical view in one T-SQL command. That really gives you the ability to insights or get data insight from both of those sets of data, which is one of those critical components of making real-time decisions now that most customers are looking for.
And
This is
this is a piece of engineering that is coming also from the stream analytics side of the Microsoft ecosystem, right?
It's a combination of both, yeah. So this is one of those better together stories, again, similar to how the Power BI story. And this is the power of Microsoft data itself as an organization, just enhancing the capabilities that we have across all of our product suite. So both sides of the engineering components of this, the stream analytics side as well as the SQL side, really work together to build a story that makes the integration experience very simple and very easy. If you think about why this is important. Most companies now are starting to emit massive amounts of telemetry data, and getting insight from that is critical. So having a product and a cloud service that's able to pull all these pieces of your organization together was something that just naturally fit. And so both sides really work together to make this available today.
And this is particularly interesting for those organizations that already have this Lambda architecture in place, right? It's very common in modern Microsoft data platforms to have a stream analytics with Event Hub as well as the main elements to manage that IoT real-time streaming of data. And on the other side, the other branch or the cold path, that is the more relational data lake flavor. So this integration is basically you could say even a holy grail of trying to bring those two together without trying to put a lot of the plumbing necessary behind.
Yeah, absolutely. And if you think of the complexity you'd have to go through of setting this all up without this integration, it becomes very difficult to be able to do this in a real-time fashion. Like you introduce latency along that path. And so the goal is to reduce or eliminate as much of the latency as possible so that you can get that insight data. This also is for customers who are starting to think through the scenario of building out Lambda architectures. You think of organizations that now have a traditional data warehouse, data lake scenario where they load that data up in the Azure cloud. They're now running this, but they want to extend their environment into some new data scenario. So it's not necessarily just customers who already have a Lambda architecture, but it's customers who are moving to that path. Where they say, "Oh, well, we're a manufacturer and we've just introduced some new IoT devices on our operational lines, and we want to be able to ingest data from that into our data warehouse. Can we do that very simply?" Yes, you can, by simply setting up, event, like you said, event hubs and streaming through Stream Analytics. You can now push that right into your data warehouse and augment what you've already enabled.
This one is really, really interesting. What else do you have? Because I see you scrolling. It seems you guys did a lot of work for Ignite.
We did. We've also introduced in public preview column level encryption. So security is one of those things that at Microsoft, it's funny. We always joke about security is one of those things that people always say, you only care about it until it's not there. You don't want to be the company that shows up on the news for having a breach, right? And it's not one of the most glamorous features. You don't go into a job interview and talk about, how you built all these cool security features. You want to talk about how you built this large scale system and that kind of stuff. But they're critical to the success of organizations. If you think about the data exploration that's happening across an organization and the data democracy that's occurring, you want to be able to expose the right data to the right people at the right time. And doing that is a combination of exposing the data, but also securing and managing that data as it's exposed. You don't want to just open up your entire data set to your entire organization because in many senses, that's not appropriate. But you do want to...
For our viewers, the reason why I was so cheery before was because Matt knows pretty well I've been one of those nagging him personally for column level encryption. So it's really amazing to see there in the program. And for clients that come from the on-premises world, probably with relatively large workloads where they have very strict security requirements, this is an absolute must to have.
Absolutely. And you think of combining this with things like, column level security, row level security, dynamic data masking, some of those capabilities. It really gives you a comprehensive way of making sure that the right users have access to the right data, right? You may have, I live near Los Angeles. And so you think of the celebrity scenario down here where you have nurses who are working with, celebrity patients. You want to make sure that those nurses have only access to the right data. Obviously, they need data to treat the patient. They need to be able to access their medical records in certain ways to be able to see see kind of the critical information that they need. But at the same time, you don't want to have them access, non-relevant information. I don't need to know, as a nurse working with a patient, I don't need to know where you live. I don't need to know your phone number. I don't need to know your social security number. Those are not critical pieces of the infrastructure that I need to do my job to help serve you as a patient. So being able to eliminate kind of those areas or those vectors of attack from ways that you can have data leakage is really important. If you think of column level encryption, right, this is really giving the ability to encrypt your data so that you can kind of control what is exposed. And really, this gives you the ability to add protection keys across that data, so you can also make sure that the data is only encrypted by those that should be unencrypting it. So whether that's in the scenario I just described, whether that's the hospital administrator or the billing administrator who's now has to have that information. Hey, I don't need to have this celebrity's medical history, but I do need to have their billing information. So where do they live? What's their address? What's their medical card ID number? Those kinds of things. And so being able to expose all of those to the right people at the right time is critical. And making sure that that data is secure when it's sitting in the system, so that it can't be exposed or it can't be hacked in some way by using certificates, for example. So it's really kind of important feature that's being exposed. This is in public preview today. So customers can go out and use this feature today in their analytics systems.
Perfect. Thank you. Thank you. What else you have? You also have demos, I understand, right?
I do. I'll show some of that. So probably one of the last big areas is if you think of just kind of exposing the data footprint, we want to make sure that the system has as much capability as possible. Some of these are features that are notoriously hard to do in MPP systems, or these are capabilities that we're augmenting in some of the new services that we have. Something like merge. So this is a capability that's in SQL Server itself. We're adding this as a T-SQL language support in the MPP Synapse SQL engine, really giving you the ability to run just a simple merge, in a data loading scenario. This is currently in a gated private preview, and will become exposed in the next couple weeks, essentially with our next code push, really allowing you to be able to integrate merge. In our serverless model, if you think of the on-demand SQL components, you really want to be able to, in that model, we don't have data storage. The serverless model is truly, you give it a query, it stands up, it goes executes a query, then it tears itself down. So it doesn't store data. And in that model, you want to be able to encapsulate code just like you would anywhere else. So the ability to extend with store procedures, you can go generate a store procedure. Obviously, we support select and views and those kinds of operations today, but really giving you that code encapsulation to be able to encapsulate kind of the execution of your code is now something that's coming to Synapse On-Demand, or the Synapse serverless components. And again, that comes with our next code push that'll happen in the next couple of weeks. Probably one of the last ones, and having been around this MPP space at Microsoft for a long time, kind of the ability to do inline table value functions. If you think of, what you would do with inline table value functions, it sounds like, if you think of, I got a 100 gig database, like I'm going to throw a couple million rows in here. That's not a big deal. When you start to talk about things in trillions of rows and at petabyte scale, this becomes hard. Computationally, this is hard. So we're now introducing this as a public preview feature. Again, this will come in both the serverless and the dedicated models. Again, post-deployment again in the next couple of weeks as we do our next code push. But really, this gives you that ability to run table value functions at scale. And when we start to talk about our data warehouse as the only one running, public benchmarks at petabyte scale, being able to do this kind of data evaluation and be able to do this kind of data manipulation at that scale truly sets Microsoft apart.
That's a very interesting one. That's definitely, particularly that one. I think it's and one of the things that I'm seeing while you're start moving the screens around is that definitely the Synapse world is definitely trying to close the gap with the more traditional relational engine, right? Because many of these functionalities are features that we take for granted. We're talking about the traditional SQL Server, either the box product or in Azure SQL DB. Right. We just take it for granted, right? You take for granted that there's a merge. You take for granted that you can encrypt your columns. You take for granted you can create your own table value functions.
Right. Well, when you think so definitely the goal is always to get to, as close to parity with the SQL language surface as possible so that the developer transfer between products is as minimal as possible. We really want to make that switching cost for developers as simple and as easy as possible. Oh, this is how I would do this in SQL Server. There are clearly some architectural differences. In an MPP system, you want to do things in batch, like anything that's row level or row by row operations are going to, not going to show you the performance of an MPP system because you're essentially now an SMP system, right? You're interacting on row by row versus batch. So there's some more kind of that covers to make things like merge operations batch-based at the engine level so that we can improve performance. But one of those big transitions as developers are thinking about moving from, say, a traditional system like SQL Server on-premise is the data scale. As these data volumes start to grow, we're talking publicly about our benchmarks at 1 petabyte. Those are the benchmarks that we're running internally, and we demo this all the time. Here's a couple of petabytes in, one of the industry benchmarks that we show on stage with thousands of concurrent users. Like building at that scale is non-trivial. Running a view that has, a backing table that's potentially trillions of rows is non-trivial. And so being able to build at that scale, but take the skill experience that the developers have and be able to just expand that at scale is really critical to our business, making sure that we can expose a product that really helps grow with your organization.
And,
so that's
and that
one
is
of
that. Let's take a look at the demos. I think you already have something on the screen for us, right?
Yeah, so I figured I'd show some of the things that aren't as talked about. We have a lot of capabilities in Synapse that really we don't show all that often in stage demos. At big events we want to show off the cool new sexy features, but really there's a lot of components in here that really help an organization with their data. So the first one is really interacting with JSON data. So here we have a table, and I'll go run the query so you can see this is just JSON data, and being able to manipulate that JSON data. Oftentimes our IoT devices are emitting JSON data, so we get that data and we want to be able to interact with it. And what you're going to see here is that we've pulled apart just using some simple T-SQL functionality, this JSON into just traditional tables and columns that I can interact with. I can do something like predicate filtering on the results of those, so I can pull apart a column and I can do data type operations on it. In this case, you can see I'm doing a filtering, and it really gives us the ability to interact with all these different formats. I mean, you've heard me talk about CSV and Avro and Parquet, and now we're talking about JSON data, and be really able to interact with all of them just from simple T-SQL. So extending kind of the developers' toolkits into these small little areas really exposes a lot of different data. So you can see I can simply interact with that data just like I would any other kind of common table structure. Some of the other capabilities we talked about too were things like data masking. So when we think of the security model that we would enable in a scenario like this, again, imagine I'm that nurse working with a celebrity patient. You want to make sure that I, as the nurse, only have access to kind of the right set of data. So here you can see I've run a query. It shows just some critical kind of personally identifying information, a phone number, an email address, credit card. And you can see if we run a simple query here, we can go see if any of the data is or if any of the tables already have any masks. And in this case, we haven't set any up in the system yet, so we can go create some. And in this case, we're going to go add a mask to a credit card, and we're going to add a mask to email. Now, you can see that we can define formats, or we can use some out-of-the-box formats for each one of these kind of operation types. And it really gives us the ability then to kind of control what our data organization requirements are. Some organizations have stricter requirements around things like masking credit cards, and some don't. In this case, you can see we're going to expose the last 4 digits of our credit card. So now if we run that query again, you can see that we have a couple columns that are masked. You can see the function that we're masking it with. And I'm going to go create a user here, the sales staff user. We're going to give them select access to that table, and we're going to go run as that user so we can see what the interaction is for that user. Now, from a experience perspective, I didn't have to change anything about my query. Now, this is a simple select star, but if I had a complicated query in my view that's backing one of my data reports, I wouldn't have to go change that data set itself in order to make sure that the data is now masked. Again, this has all happened at the engine side. So you can see that data is now masked. I can also grant an unmask capability to that user or group.
Okay.
So I can go tell the system, hey, for this user, I want to unmask that, or I can simply revoke it. Maybe I want to expose it for a period of time, for example. And I have control over that here just simply with T-SQL. I'm going to go clear this all back out, right? So I can get us right back to where we were when we started. simply by altering that and dropping the mask. So through some simple T-SQL commands, I can secure my data without having to go through a lot of work of, okay, let me go build some view that is masking the data for certain users, and then it's not complicated. You simply just go add a mask to a column, for example. So it really makes the management of the system a lot simpler.
This one is really interesting. What is this one now?
Yeah, so I'm bouncing through these fairly quick, but we were talking about column level security before. So here's one of those scenarios where we can look at the column level security. So again, I'm going to just run a simple query here. You can see all of my data. If we look at some of these columns, maybe potentially kind of data that we don't want to expose to everybody in our organization. Maybe we don't want to have a product category with revenue targets that we expose to everybody. So we're going to go create a couple of users here. I want to make sure that they're exposed. Yep, there they are. And we're going to go grant select on these capabilities. So here what we're going to do is we're going to give them, to the sales staff, we're going to go give them select on particular sets of columns. So if we go look at that table, if I go run this, you'll see that I get denied access because I'm trying to get all of the columns. I don't have access to the revenue column, and that was delineated before. So now I've only been given access to this set of columns. So I can go through the process of running that same query, but I'm now limiting what I can see. So I have the revenue target, but I can't actually see the revenue that we generated so far. It's maybe not something our sales staff needs to know. So I can limit the amount of data that is exposed, even though my table contains all of that data. So now I'm going to go back and I'm going to go look at the inventory manager. Now, if I run as the inventory manager, that customer has, or that user has access to all the columns. So they can simply run a select star and they can see all of the columns themselves. So they don't have to go through the process of building out the specific kind of delineations of, oh, well, I'm an inventory manager, so I don't have to, or I have access to all columns, but I'm the sales staff and I don't. So very simply, just by giving simple grant statements, we can control who has access to see what data. And this really exposes, the control of what data you're exposing to your organization. You want to make sure you have some level of control over that to ensure that, again, the right people have the right data at the right time, and really granting and controlling that access. One of the things that you see, I'm calling out that I'm acting over as a user here, but this can also be applied to groups. So when you think of a sales organization, typically you have something like Azure Active Directory integration, where users logging in using their corporate credentials on premise, that then gets pushed into a group that's managed at the SQL level here within Synapse. And then the user is automatically controlled, their permissions are controlled to that group. So you don't have to manage individual users. Typically, this is done at a group level. And this is really great because as users leave your organization or they leave maybe that part of your organization, as soon as they're gone from your Azure or your Azure Active Directory group or your on-premise Active Directory group, they leave the organization, for example, and their account is disabled or removed from your AD, that instantly reflects inside of your organization. So as the user leaves, you don't have to think, oh, okay, do they have a login to our our cloud service, and do I have to think about going and managing that? It's fully integrated.
This is really, really powerful. Particularly this one is really, really powerful. And again, this is probably for those of you that are not that familiar with some of the more fundamental database or SQL management concepts. I want to highlight something because I know some of our viewers we're just starting on this journey, right? Please do not manage your security on your databases or in general in any repository only by user. Please use leverage Active Directory either in Azure or in on-premises. Please use Active Directory groups. They are really lifesaver. You don't want to end up with hundreds of different users, you having to chase them all around in your database.
Absolutely. That's one of those common scenarios that as you think about extending Active Directory into the cloud and then being able to expose that to users here, it also helps make the experience seamless for the user. They don't have to think about, oh, what's my username and password for this service? Like I just log in with my corporate credentials. This is a row-level security demo, so this is really the same thing, exposing data to the right sets of users at the right time. Again, this one's a little different. So what we're going to do is we're going to go look at this function here. We're going to create a function, and what this is going to do, oops, I don't have the security permissions. It should be created. All right, well, we're going to skip over this one. This is one of those, there's a bunch of us doing demos this morning, so I think I got bumped out. But really Yeah, it's one of the problems with doing demos all
The
the
demo gods have abandoned us today,
That's
viewers. So
okay.
sorry about that.
It happens. But essentially the idea is that based on different organizations, you'd be able to see different, data sets. So for example, if I was in the sales staff in San Diego, I would only see, say, my San Diego data. Or if I was in sales staff Miami, I maybe only see the Miami information. But if I was the inventory manager, I could see all of it. So based on my rights and privileges. So pretty straightforward. So we'll hop over that one. This one's just a simple demo of the copy command. It's not super glamorous. I just wanted to expose it here so you could see it. Really, the idea is that I've created a table here, and now I'm just using some simple T-SQL command to go say, this is where I want to get my data. This is the type of data. I'm using a SAS key here as my identity key, and then here's the key. And essentially, if I run this, it'll actually go through this data loadings. And you can see I've already done it here, but it really gives you that capability of just running a simple command of loading data out of blob storage, to be able to pull that data in very quickly if it's data that you already have laying around. So you don't have to go.
This is really the cloud version of VCP, right?
Yeah,
Extremely efficient on data transfer.
Essentially, yeah. So it makes it very, very fast. The last one I'm going to show you is this on-demand capability with being able to connect to Cosmos DB. So what this is an open row set. You can see we've now switched over to our on-demand server. And so I'm going to go select some columns out of essentially an instance that's running here on Cosmos DB, and I'm going to give it some information. Now, I'm going to run this first query here. And what we'll do is we'll be able to run this query. And what's happening is the SQL on-demand engine is now standing itself up. It's reaching out into Cosmos DB, and it's pulling that data back. And you can see it took about 7 seconds for it to happen. So we're able to now get that real-time insight data based on an on-demand query. And if I run this again, it should execute quite a bit faster because the engine itself is now up. And so since the system is up, I don't have to worry about that kind of construction of the cluster to be able to go execute the query. So you can see the second query here was much, much faster. But I'm able to interact with real-time data coming out of Cosmos DB. You can see I'm getting real results out of Cosmos DB by simply just running a query into it. So I no longer have to wait for the latent data to come through an ETL or ELT kind of pipeline. It really shows the power of this.
Really fast. That was a really, really quick operation. The first one where you were revisioning, that was really blazingly fast.
Yeah. So I'm going to switch over since I'm a longtime SQL Server guy, and SSMS is the tool of choice for me. Any tool I can't hit F5 to execute a query is kind of, makes it hard for me. So I'm going to show that you can still interact with all of these systems in the same ways that you've been familiar with. So if you're used to working with SSMS or Visual Studio database projects, all of those integrations are still there. So I'm going to run one of these, benchmark queries, and this is now running what we call a DW3000C. It's a 6-node MPP system. So this is the SQL dedicated server component. And I'm going to run a timing script around this. Now, what's happening right here is the system's going out and executing a query. It's going to build a distributed plan. It's going to send it out to the 6 individual nodes. The individual nodes are going to process their components of it. They'll return their intermediate results to the parent node. That parent node, in this case, will do some final aggregation and some sorting and that kind of thing. And you can see it took about 15 seconds or so to run. Fairly good, considering this is about 10 terabytes of data. So it's not too bad. I'm going to show you what's actually happening here. So I'm going to just simply show you the estimated execution plan. And you can see that there's quite a few steps in this. Probably the most costly is this shuffle here. So, but you can see from the performance of the system, it's not bad, but it's still executing quite a few steps. Now, we have some capabilities to make this better. So the first one I'm going to show you is a materialized view. Now, a materialized view, I want to make sure I don't have it sitting there, is exactly like it sounds. If you're familiar with materialized views from other systems, then you're familiar with this concept. If you don't know what they are, essentially it's a pre-calculated view. As the underlying data changes, the view is automatically pre-calculated and you have the intermediate results of the view staged. And where this becomes important is if you think of a traditional view, all it is an encapsulation of code. It's saying here's some code that's defined in a particular way, but at execution time, we want to be able to go and start the query at some intermediate step and not having to go through all of those steps to get the query data. So that's where materialized view comes into play. Now, what's important here is that I've created the materialized view, and I'm going to go rerun my query. Now, you'll notice I haven't changed anything about the query itself. So from a user's perspective, I've written my dashboard. I've got all my queries exactly the way I want, but I need to tune them or make them faster. So if I go run this query, wait a second.
Wow.
266 milliseconds.
Wow.
We went from 16.5 seconds to 266 milliseconds. Now let's go figure out what happened. How did this get better? If we go look at the estimated plan, wow, you'll see that it's a much simpler plan. We got rid of all of those complicated shuffles and broadcast moves and all of the data movement operations that are happening because the view itself is pre-calculated and holding those intermediate results. And so here you're able to see the performance of the system being able to take advantage of that materialized view. Now, what's important is that as a developer, I didn't have to change my underlying query. I didn't have to go, oh, okay, well, let me go rewrite my selects. I didn't have to do any of that. The view itself and the query engine itself can take advantage of, oh, here's a query that could take advantage of one of my existing views and automatically switch over in the middle of the query execution cycle to be able to take advantage of that materialized view. And this is extremely powerful when you start to think about the application of this. Now, one of the things I'm sure I'm going to be asked is, how do I figure out what I would create a view for? Right?
Since you know us quite well by now, man.
Yeah. So, because hey Matt, that's awesome that you figured that out. Like, but how do I figure that out? Because I don't know this stuff. So what we have is we have what we call an explain, and this really shows you the estimated plan. It's an XML version of what you just saw essentially, but we've introduced this with recommendations keyword. So I'm going to execute this, and you can see it drops an XML file. I'm going to go to my old friend Internet Explorer. And I'm just showing that same explain. And what you can see is it shows all of the steps. So here's the SQL statement that I want to run. And here's all those operations that you can see under the covers, all those shuffle moves that we were talking about before. But near the top, you have these two materialized view candidates. And you can see that there's the actual T-SQL syntax that's there for you. And you have two choices, whether we have the constants, in this case, here's the smoke that we're looking for in the filter, or without that. And you can choose which one to implement. And so this really gives you the capability of being able to quickly identify in a slow running query if a materialized view would help and what the definition of that view would be. So you don't have to go through and sit and tinker with it. You can actually get the system to automatically recommend for you, here's a materialized view that you can generate. So I'm going to go drop that view, and I'm going to show kind of the last thing that we have here, something that doesn't get a lot of love. So this is that same query. If I run it again, it's going to take about 15 seconds or so to execute. But we have a capability that we call result set caching. And you can see I don't have it turned on here, but I'm going to go turn it onto this database. This will take 10 or so seconds. And really what result set caching is doing is as a query is executed, the intermediate results that are executed and that come out of the query are then cached. And where this becomes important is if you think of a dashboard scenario, everybody comes in on Monday morning and they hit the primary sales dashboard. Well, most of those queries are going to be the exact same thing. Everybody's filtering on the same sets of dates. They're looking at the same product kind of, sales history over the last 90 days, those kinds of things. So the first user incurs the pain of actually executing the query, and then the results are then stored in a cache. Every subsequent user of that system now has that cache data. So let's go simulate what that looks like. So we're going to go take our query, and here I am, that first user of the day, and I'm going to go run my query. And this should take about that 15 seconds, right? I'm flooding the cache with the results. And what this does at the meantime is, while we're waiting for this to execute, is that first query is now a concurrent query. It means that I'm taking up some concurrent query execution slots from the system to be able to go execute the actual query. Now, in an MPP system, this isn't like your traditional SQL Server system where you have thousands of inserts all happening at all at the same time. In an analytics system, you really work over these latent queries. We're talking about petabytes of data. You want to be able to execute those as quickly as possible, but you don't scale those all that well, right? Most systems only have, hundreds of concurrent queries executing at a single time. But if you want to be able to expose that real-time data that we've introduced with Stream Analytics and Cosmos DB Link, or through Synapse Link, and you want to be able to expose this to Power BI, we want to make sure that all of those users can access all of this data as quickly as possible. So now you see it took about 17 seconds to run, like what you'd expect. But if I run this again, you can see it's 100 milliseconds, just a little over. And that's because this data is now cached. I didn't incur any concurrency slots in the system, and I simply just return the results. And if I run this again, you'll see that this is consistent time and time again. And this really gives an organization the opportunity to add result set caching, to your system to be able to scale out your data footprint, expose it to more users, to be able to, really optimize the performance of the system, and sometimes even reduce your cost by not having to run as large a cluster because you're not computing these queries over and over and over again, the same queries constantly throughout a day. And this really gives organizations that ability to scale, to a wider set of users who can really access the system. So if you think of all the data analysts in the company, you want to make sure that they're exposed to all this data and can really see and access it in as near real time as possible. So things like results and caching really help with that. So that's all the demos I have.
That was intense. It was intense, really intense. But thank you very much, Matt. It was absolutely amazing. I think we're seeing some very powerful innovation, a lot of homework for all of us after watching this video, and hopefully you can take it back to the developers of these not so often talked about functionalities, that we love them, that we like them. For everyone else, please don't forget to subscribe. You'll see the link here somewhere. And Matt, thank you very much for joining us. It's been a pleasure to have you with us.
Yeah, thank you for having me. I always enjoy talking to you guys.
Thank you very much. To all of you, thank you. Have fun. See you next time.